Eric Archer here with another Smart Space video lesson. Today we're going to be working with Craig Beals, a chemistry teacher, and Craig's going to help break down the concept of stoichiometry, but he's going to do it in a unique way. Craig, tell us about stoichiometry today.
Well, we're basically gonna deal with food to learn the basics, or really the top surface of stoichiometry. Everybody likes sweets, so we're gonna use sweets as our example.
That is awesome.
So stoichiometry is the term I use in my introductory chemistry class all year long to talk about. We're going to have to know all these building blocks to be able to do this one big thing that we call stoichiometry. And in this introductory lesson, you're going to get a little bit of background about what stoichiometry is, what limiting and excess reactants are, and mostly we're going to apply that all to s'mores, which are a super yummy, sugary treat. First of all, what is stoichiometry? So there's something called the law of conservation of mass, and it states that the mass of the reactants in a reaction must equal the mass of the products. In other words, mass can neither be created nor destroyed. So if we look at this example, we have methane and we have oxygen. So those two are combining together or combusting to form CO2 and water. And what you see in this equation are some coefficients here in front of the oxygen, in front of the water. Those coefficients help balance this equation out. So let me get there in just a little bit. And what I mean by balancing that has to do with the law of conservation of mass. So stoichiometry uses this law to calculate the quantities of reactants and products used in a reaction and the amount that might be left over after the reaction is done. So let's go back to our equation above, but use an example. How many grams of CO2 are formed from the combustion of 25 grams of methane? Let's go back here. That means if we're starting with 25 grams of methane, this stuff right here, how many grams of this stuff are going to be produced? That's stoichiometry. Okay, we can take it one step further and figure out, all right, well, how many grams of this are going to be produced? And how many grams of that are we going to need if we have this amount? We're not going to go quite that deep. Instead, we're going to use yummy foods to figure out how this works. You've maybe done something like this before. So you didn't call it stoichiometry, but it might have been stoichiometry. For your birthday, let's say you decided to bake chocolate chip cookies for your chemistry class, which is always highly encouraged in chemistry class, at least in my chemistry class, unless it's a lab day and then we can't eat cookies. So you find your favorite recipe and you set out to determine how much flour, sugar, chocolate chips, eggs, and everything else you need to buy so that all 30 students get a cookie. Now that seems simple enough, right? You know how much flour, how much sugar, how many chocolate chips go into each cookie. You can start to figure that out. The trouble is, flour can't be bought in a certain amount of cups, and chocolate chips can't be bought by a certain number of chocolate chips. You need to buy them by the bag. So then you need to figure out, well, how many am I going to have? And then you probably have some left over in the end. But if you didn't buy enough of one of them, you didn't make enough chocolate chip cookies for everybody in your class. So you figuring out how much you need, that's stoichiometry on a very simple level. We're going to apply this to s'mores, which is one of my favorite treats. S'mores, and this is my really, really poor diagram of a s'more, so bear with me. I'm not an artist, I'm a chemistry teacher. But this is a s'more. A s'more has 2 graham crackers. Those are these things right here. It has a marshmallow, which should be roasted and toasted perfectly over a campfire. And then it's got chocolate pieces. We're using 3 chocolate pieces. My students always tell me 3 is never enough, but that's what we're going with. We're going to take this example and we're going to turn it into a balanced chemical equation. Here's our balanced chemical equation right here. We're going to say that 2 graham crackers, those 2 things, plus 1 marshmallow, plus 3 chocolate pieces react to form or to synthesize 1 s'more. Okay. Let me grab my calculator. If we apply this to s'mores, here's what we've got. Let's say I have 125 students that I need enough supplies that each one of them can make a s'more. That's 125 s'mores. How much of each ingredient will we need, or how much will I need to buy? In order to answer this, in order to answer any stoichiometric problem, I need a balanced chemical equation. Here's my oversimplified balanced chemical equation. And what I have to do is use dimensional analysis in stoichiometry to answer the problems. First thing I do is write down what I know. I have 125 students, therefore I have 125 s'mores, or I need 125 s'mores, SM. And I need to turn that into, well, first let's figure out graham crackers. Now, some people might be saying, wait a minute, this isn't that hard. I can look at those numbers and figure it out. Yes, you can. But once you get into complex numbers being used in chemistry, it isn't this easy. So what we're doing right now, we're learning the process. We're learning the process of how you do stoichiometry, all right? So I've got s'mores on the bottom as a unit so that those two will cancel, and I'm gonna put graham crackers up here. Now what I need is called a mole ratio, because I have s'mores down here and it looks like I have a 1. So for every 1 s'more, how many graham crackers do I need? I need 2. That's my mole ratio. These are going to cancel, and I'm left with graham crackers. And then I take 125 times 2, which fortunately I think I can do that one on my own. That's 250 graham crackers. We're going to put that over here, 250 graham crackers. Okay, the next one I need to do is marshmallows. So I still need 125 s'mores, and I need s'mores on the bottom to cancel. I can turn that into marshmallows. And I look up here at the coefficient. I have a 1 in front of s'more, and I have a 1 in front of marshmallow. Again, people are like, well, wait a minute, this I don't need to do all this complex stuff. But remember, we're just using this as a simple example to learn the process. I need 125 marshmallows. And then the next one, I need 125. That color is really hard to see. I need 125 s'mores. And so I'm going to put s'mores on the bottom to cancel. And then I'm going to turn that into chocolate pieces, so CH. And it looks like for every s'more, I need 3 chocolate pieces for every 1 s'more. That's my mole ratio in our example. And that gives me 375 chocolate pieces that I need. CH. Okay, so this is the foundation. This is just the basics of stoichiometry. Let's alter this a little bit to make it a little more realistic when it comes to chemistry. Going the wrong way. Okay, I think this is it. Let's alter that to make it a little more realistic. You decide to make a batch of s'mores. You already have some chocolate, so you don't want to go buy more chocolate. You're just going to use what you have. You have 85 chocolate pieces. How many s'mores can you make? And how much of each other ingredient are you going to need to be able to make all of those s'mores? Now, again, this just takes us right back to dimensional analysis, which we have 85 chocolate pieces. Ooh, let's do this. We need our balanced chemical equation up here. There we go. So we've got, let's see, 85 chocolate pieces. We need a conversion factor with CH down here on the bottom to get rid of our chocolate. And we can turn that into s'mores right here into SM. We just go up here to our balanced chemical equation. The SM, we have 1 s'more requires 3 chocolate pieces. Those will cancel. Let's type that into the calculator just to make sure I don't make any mistakes. We have 85 divided by 3 equals 28.33. Now, wait a minute. We've got a problem here. 28.33. That means I'm trying to make 0.33 of another s'more. I can't do that. I have to make whole numbers. And this is where it starts to become a little more realistic with chemistry. I can't have those there. In other words, I can make 28 s'mores. Am I going to have some chocolate pieces left over? Yes. And stoichiometry will help me figure out how many I have left. We're not going to go quite that far, but I'm going to be able to make 28 s'mores. The second part says, how much of each other ingredient am I going to need? Well, if I can make 28 s'mores, I just do another little piece of dimensional analysis, and it looks like I'm trying to turn that into graham crackers. I come back to my balanced chemical equation. 1 s'more is equivalent to 2 graham crackers. That's my ratio. And so I have 28 times 2. That should mean 56. And then I go back. I know I can make 28 s'mores. And I want to figure out marshmallows. So I put s'mores on the bottom, marshmallows on the top. 1 s'more and 1 marshmallow. Ooh, we like that math. That makes it easy. That's 28. So I need 28 marshmallows to be able to do it. Again, super simple steps for stoichiometry. A couple other things that you need to understand with this. It's limiting reactant and excess reactant. Let's start with limiting reactant. Limiting reactant is important. It's the reactant that allows you to make a certain amount of stuff. In our last example, that was our chocolate pieces, because that's what we started with. So let's look at this in a little bit different way. This is not my balanced chemical equation. This is just how much of each I bought. There's my balanced chemical equation. If I bought 10 graham crackers, or I have 10 graham crackers, 5 marshmallows, and 12 chocolate pieces, the question is, how many s'mores can I make out of this? Well, I kind of need to dissect it with each one of the different problems to figure that out. Let's do that. So I start with what I know, which is 10 graham crackers. I'm going to put graham crackers down here so they cancel. And I'm trying to turn that into s'mores, right? To figure out how many I can make. And I know from my balanced chemical equation that I need 2 graham crackers for every 1 s'more. These will cancel. I've got 10 divided by 2. That gives me 5 s'mores. So I would be able to make 5 s'mores if all the rest of these work out. At least I have enough graham crackers to do that. Let's try the marshmallows. I've got 5 marshmallows. I need marshmallows on the bottom to cancel that out. S'mores on the top. Got 1 s'more, requires 1 marshmallow. Those will cancel. Looks like, oh, from the marshmallows I currently have, I can make 5 s'mores. So we're looking like it might be 5 s'mores is the answer. Let's check the chocolate pieces. I've got 12 chocolate pieces. I'm going to put chocolate down here and s'mores on the top. I look at my balanced chemical equation. I need 3 chocolate pieces for every 1 s'more. 12 divided by 3 is 4. Ooh. I noticed I made a mistake right here. This is 5 s'mores. That happens sometimes. Sorry, I figure I better correct that now since I noticed it. 4 s'mores. Well, look, here's what this means. That I've got 12 chocolate pieces is only going to allow me to make 4 s'mores. And just because I have enough to make 5 s'mores of all of these things doesn't mean I can make 5 s'mores. I can't. Because right here, I only have enough to make 4. So let's talk about that. That means my chocolate pieces is my limiting reactant. It determined how many s'mores I was able to make, which is 4 s'mores. Do I have anything left over? I'm not going to have any chocolate pieces left over because I used them all up to make those 4 s'mores. But look at here. I'm going to have some of these left, aren't I? I'm going to have some of my, what was this, graham crackers, and I'm going to have some of my marshmallows left over because I could have made 5 s'mores, but I didn't have enough chocolate pieces. That takes us to the next part, which is called an excess reactant. So excess reactant is any reactant that remains, is not completely used up entirely during the reaction. And I need to go through the same thing, so I'm just going to write these out just like we did before. And I've gone ahead and I've done the calculations for this. With that many graham crackers, I can make 1 s'more. With that many marshmallows, I can make 1 s'more. With 5 chocolate pieces, because I don't have enough to make another s'more of anything else, I can still only make 1 s'more. but it looks like I'm going to have some left. In fact, you can figure that out because I used up 3 of them and I had 5 total. I'm going to have 2 chocolate pieces left. My excess then is 2 chocolate pieces. My limiting reactants, well, basically it was both of these because both of them only allowed me to make 1. And the chocolate pieces was as well because I didn't have 6 of them, but I'm just going to list the first 2, graham cracker and the marshmallow were my limiting reactants. Stoichiometry gets really, really complex. This is just the very beginning of starting to understand what stoichiometry means. But Texas Instruments has a whole bunch of things built into the Nspire online and other lessons that you can go to find out more about stoichiometry and also to do stoichiometric practice problems right within the Nspire.
Craig, this is great. Thank you so much. I've never seen stoichiometry taught with s'mores before. So this is a first. I wish I'd learned stoichiometry with s'mores when I was younger because it's fantastic. The only thing that could be better is if you actually had s'mores. You know?
Hey, come on out to my classroom. We do this with actual s'mores in the classroom every year.
Oh my goodness, that is fantastic. Yeah, that's an awesome classroom. But what I really like most about it is you took a really simple and fun and sweet example and you kind of showed us the process of using stoichiometry to figure out your answers. Because yeah, stoichiometry for a lot of kids can be a little scary and a little intimidating at first. And you broke it down, you simplified it, and you used a fun example with easy numbers. And so great job, great lesson. And thank you so much for showing us how to do stoichiometry with s'mores.
Yeah, no problem. Thank you.